The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
We tried to make our products as flexible as we could in terms of different applications. So you could do a large, multi-megawatt ground mount, or you could do a smaller community solar, which is only maybe a megawatt or so. And we've designed our products with the field wiring box so that it can be, for our 100, 125, you can either use a what we call our distributed architecture, or as you mentioned, you can do what they refer to as a virtual central. You're essentially mimicking the architecture of a central inverter, but you're getting the benefit of a string inverter.
Are you speeding the energy transition? Here at the Clean Power Hour, our hosts Tim Montague and John Weaver bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
Today on the Clean Power Hour, the evolution of the string inverter in solar technology. I'm Tim Montague, your host. Welcome to the Clean Power Hour. Check out all of our content at cleanpowerhour.com. Give us a rating and a review on Apple or Spotify, and please tell a friend about the show. Today, my guest is John Drummond. He is the Senior Applications Engineer at CPS America, and we are going to be talking about how he sees the industry changing, how products have evolved over time, and whatever else comes up. Welcome to the show, John.
Thank you, Tim. Nice to be here. Thanks.
This has been a long time in the coming. It's great to have you here on the Clean Power Hour. We're about to spend some time together in Dallas, Texas, at your annual event. Looking forward to that.
That's right.
But give our listeners a little background on yourself, John. When did you get into the solar industry, and how did you come to CPS?
Yeah. So I kind of fell into the renewable energy industry by happen chance. I had a friend who worked for a company called Kinetec Wind Power. This was way back in the mid-90s. And they happened to have an opening in their engineering lab for a technician role for what they referred to as non-wind projects. So this was kind of exciting and new. So I took the role and was hired. And what they were doing was taking some of the sub-assemblies that were designed for the power conversion cabinet for the wind turbine, and taking these, IGBT bridges, controller boards, and so forth, and applying them for other renewable energy applications. One of them being grid-tied solar. We also did adjustable speed drives. We did some converters for flywheels, fuel cells, advanced batteries, you name it. I mean, it was just kind of exciting, cutting edge stuff. So it was a kind of a great move for me. So I started with Kinetec Wind Power in 1995 in this role. And just about a year or two after that, Kinetec had some financial trouble and had to file Chapter 11, a reorganization. And the department head of the engineering department was a gentleman named Bill Erdman. Many of your listeners may know or hear of Bill Erdman. He was one of the founders of BEW Engineering. It was Mike Benke, Bill Erdman, and Chuck Whitaker that started that business. They were a third-party design consulting firm. But anyway, we spun out of Kinetec and started a company partnering with Trace Engineering, and we called ourselves Trace Technologies. Trace Engineering, as you know, later was acquired by Xantrex. They designed the XW off-grid, and We were doing utility scale stuff. Utility at the time was a 100 kilowatt inverter. That was big time, big deal.
Right.
Kind of exciting stuff. But yeah, so just kind of fast forward. I worked with them. They were absorbed by Xantrex. We did some kind of standard grid type products. Xantrex had their GT series. So some of your listeners may be familiar with those old GT series. And then Schneider Electric absorbed Xantrex and did some further development. And then about 2015, I made the transition to CPS. And CPS was focused primarily on string inverters. Schneider and Xantrex were doing central inverters. So there was this kind of wave, this shift in the industry that happened probably late 2008, 2010 timeframe. And that stemmed from a change in the National Electric Code, which allowed for ungrounded PV systems. So essentially a floating array. This happened primarily in Europe, was being allowed, but everything in North America here had to be solidly grounded. So these are back in the days when you only had a 600 volt DC array, and either, typically the negative pole was grounded. In some cases, like for SunPower modules, the positive pole was grounded for efficiency. But that allowed a change in the industry to do what we refer to as a transformerless inverter, or essentially a string inverter.
Yeah.
Where it no longer required an isolation transformer, because there was not a DC ground and an AC ground that needed to be galvanically isolated from one another. Because the array was floating, you could no longer require a transformer. This transformer was simply just a step-up transformer if you had a different service voltage. But yeah, that's really how that came about.
So why is that? Why is that such a big deal? The transformerless inverter.
Yeah. So great question. So one thing it does is it makes the inverter much lighter, because you don't have all this iron and copper inside it, right?
Yep.
Or maybe an associated transformer with it. So that meant that a 50 kilowatt inverter, instead of being the size of your home refrigerator, is now the size of a backpack or a small suitcase.
Right.
It doesn't have to have that isolation transformer in it. And then there were some other changes that were happening at the same time, and that was IGBT module technology and what was referred to as 3-level inverters rather than a 2-level inverter. So many manufacturers took advantage of that, which meant that for a 3-level inverter, instead of having 2 IGBTs in series, one from the neutral point to the positive bus and one from the neutral point to the negative bus, you would have essentially 2 IGBTs in series, which meant that these IGBTs could be half the rated DC bus voltage, and much smaller footprint, much smaller heat sink, which also would add weight, and efficiency got better in this case for a 3-level inverter. So there were some major changes which allowed for string inverters, and primarily the one was allowing for an ungrounded PV system.
Okay. Now, you mentioned Xantrex, a well-known name today they're a well-known name in portable
Correct.
Power systems, RVs, sailboats, trucks, etc.
Yep.
But is that a subset of, like you mentioned that Schneider absorbed Xantrex? Did they spin off a portion of that or something like that?
Yeah, that's exactly what happened, Tim, is they had their large inverter line, I guess you want to call it.
Yeah.
And then these were inverters that were, they're, as you mentioned, these mobile devices are like for RVs, for a long haul truck or a marine. They're down in like the 2 to, less than 10 kilowatt size.
Right.
And many of them operate off grid. They're a voltage regulated mode. So they sold the solar line of business over to Xantrex. And those were their quote utility scale. Xantrex manufactured everything from a 30 kilowatt inverter up to a half a megawatt, a 500 kilowatt central inverter.
Okay.
Yeah.
Well, it's a little awkward, I have to say, talking to somebody who's so technical, because you use a lot of lingo that I don't truly understand. But let's go further. Like, the modern PV industry really started in the U.S. in 2010. Of course, there are many people and many segments of the industry started earlier than that. I mean, the technology itself goes back to the 50s. And so much of solar PV technology is truly very mature and now has become quite commoditized. And, solar panels are the greatest example of this. There's probably over 100 solar panel makers. But anyway, inverters are still an extremely important part of the array. They're a less recognized. They're behind the scenes more so, right, than the solar panels.
Right.
Right. And I like to say they're the heart of the solar array, though. They're doing the heavy lifting, converting the DC power to AC, and which is an essential role. But if you think to 2010 and forward, I recall talking with Mike Hall about the early 2000s. I think in 2002, we were doing 1 megawatt of solar a year in the United States, right? And last year we did 33 gigawatts.
Right.
So
right.
It truly has been a rocket ship. But how have things changed since the 2010s? And when did you join up with CPS?
Yeah. Well, I joined up CPS in 2015. That's when I departed from Schneider Electric.
Okay.
But at Schneider Electric, I wore a few different hats. So I had different roles in my career through Xantrex and Schneider, and it was always kind of involved in product development, bringing new products to market, but also compliance and testing, and then sustaining engineering. So I had some experience under my belt when I came to CPS, and the role I took, which I still have, is application engineering. I was promoted to a senior a couple of years after I joined. But back to your point about what is the evolution of string inverters that's happened over the years is, one big thing is the advancement of some of the autonomous functions that inverters can do to help with grid stability. A few years back, there was a committee formed, a Smart Inverter Working Group, and they came up with these autonomous functions to help with, voltage and frequency stability of the grid. Today we have inverters that are connecting to the grid that are providing all kinds of services like this. They're not just a box that does power conversion. These are sophisticated computers, essentially, that are tied to the grid and performing these services. They're able to dynamically inject reactive power for voltage stability in what's referred to as a volt var mode, where they're monitoring the grid voltage, and if it's either rising or falling, they can inject or absorb reactive power for that stability. These are great features in terms of string inverters to deploy this. There are national standards now that require this. Hawaii, the HECO utility group was one of the first to require smart inverters on their grid, just because the stiffness of the grid in Hawaii. So that was a requirement. It also stemmed from Germany.
What do you mean about that, the stiffness of the grid?
Well, in the terms of, you've got a generation plant, and everyone's expecting their power to be at a nominal voltage and a nominal frequency. And when you start putting loads on this grid, it can change the dynamic of that service in terms of either If you've got capacitive or inductive loads, it can do a frequency shift. In terms of a reactive load, it can bounce around. I'll use that term in terms of loads turning on and off. Big loads I'm talking about.
Yeah.
And these inverters can help, that have these smart grid functions, can help stabilize that in terms of what we refer to as a weak grid.
Okay. So I love this expression, the computer of the grid. It is much more than doing power conversion. It is making the grid smarter. And ultimately, we have to remember this, that while solar does present some challenges to grid operators, like the duck curve in California, which is non-trivial, it is also a tremendous resource and can do smart things. And with the advent of smart inverters, right? UL 1741, I believe, is the specification, right, that allows the grid operator to, control the inverter remotely and throttle it if need be. It
used to be so 1741 is the safety, the product safety standard, and that's the go-to that everyone certifies their inverters to. Then they added what they referred to as Supplement A, and Supplement A were the smart inverter functions, and it was basically what they referred to as an SRD, a supplement requirement document that you had to adhere to, in addition to the safety requirements. Safety requirements were like, is your inverter going to catch fire? If you introduce an abnormal by, disconnecting a gate lead to an IGBT, does it blow up or does it just cease operation? Those kind of things. So with the introduction to Supplement A or 1741 SA, there was these new grid services that came about. And this was really beneficial because, as I mentioned, it aided in grid stability, but it also meant that if there was ever an abnormal event on the grid, the inverters were required to ride through this event rather than quickly disconnecting. It used to be that if there was an excursion outside of voltage or frequency, you had to disconnect within either seconds or cycles. Mm-hmm. And there's a famous event that happened in Southern California back in, I'm trying to remember what year it was, but it's referred to as the Blue Cut Fire. And your listeners can probably go Google that and find out. But it was
Blue Cut or Lou Cut?
Blue, I'm sorry, BLUE.
Okay.
Blue Cut Fire.
Okay.
And it was a vegetation fire that affected some high power tension lines that in turn caused a frequency a frequency anomaly, and inverters that were a large PV plant, a multiple plant, like megawatts, saw this and disconnected. And unfortunately, it started this kind of cascading event where the next plant saw it, and it made it worse and worse. So this was some forethought about, this doesn't make any sense to quickly disconnect. We need to allow these smart inverters to be able to ride through these disturbances. And so now there are ride-through requirements where an inverter must wait so many seconds, and sometimes it's as many as 13 seconds to 20 seconds to ride through an event before it makes a decision to then disconnect.
Oh, fascinating.
Yeah. So, it's all about aiding in the grid stability. So the recent update is 1741 SB, so Supplement B. And that added some additional smart inverter features where there are now communication and scheduling requirements included. They updated a interconnect standard that everyone may be familiar with, is IEEE 1547. And the updated version is the 2018 version. And accompanying that is a test protocol document of how are you supposed to test to this 1547 document. That one's 5047.1 2020. So a lot of utilities now are beginning to adopt these requirements. So they want what they refer to as SB certified inverters. I'll be happy to share that I'll kind of put a feather in my cap here that CPS was one of the first inverter manufacturers to receive this certification for all our products. There was a delay in the process for many manufacturers that was affected by COVID, and that was, scheduling with the NERDLs to have these tests performed and being ready with equipment. So utilities were saying January 1st of 2023, you have to have this equipment certified and ready to go. And it turned out that there wasn't a lot of equipment on the market available. So the decision was made to push back the deadline. And some utilities were changing the requirement where if it was under a megawatt, then you could use the old SA certified equipment. And if it was over, then you would adopt it, or vice versa. So those are changes, and all changes for the good, because these are just making these, I mentioned computers, just making these computers better and better.
Yeah. Explain the difference again, SA versus SB.
So it stands for Supplement A, and it's just a Supplement B is just an addendum to Supplement A.
I see.
So it's an extension of the requirements. So
yeah,
really SB includes all the requirements of SA plus a few extras.
So inverters are getting smarter, they're getting smaller, they're getting lighter, more capable. And meanwhile, the adoption curve is going through the roof, right? And so there's this intense pressure, though, on manufacturers, right, to evolve their products and come up with new and better designs. Tell us a little bit about that. How does that work at CPS? Because you have a constant flow of new products coming to market, and you've obviously seen quite a lot of that in the 8 years plus you've been at CPS now.
Yeah. So back to the change of ungrounded PV systems. The other change was going from a maximum open circuit voltage of 600 volts to 1,000 volts. Used to be back in prior to, I want to say, like 2005 era, some of manufacturers were getting pretty clever with this maximum 600 volt by doing what they called a neutral point. So on the DC side, and they had a 1,200 volt array that was tied into the inverter so they could get greater voltage. So simple Watt's law, if you increase the voltage for the same power, your current is going to go down, which means your conductors can go down. Mm-hmm. Or conversely, you can get more power with the same current and a higher voltage, right? So that started to happen in the string inverter market, where many inverters went from a 600 volt DC. CPS used to make a 14 and a 20 kilowatt inverter that was a 600 volt DC. It was a ungrounded PV system back then, but then they went to 1,000 volt. And again, just Watt's law just made sense. 1,000 volt DC is the maximum allowed under the NEC for open circuit voltage for PV systems on buildings.
Right.
So on a single family dwelling and a two family dwelling, it's 600 volts DC. So that's all residential. On a building, it's 1,000 volts. And then there are other applications over 1,000 volts, like 1,500 volt DC ground mounts. I was just at the NABCEP conference this week, and there's talk of module manufacturers going to a 2 kV module, so 2,000 volts. And there may be some pilot projects coming out soon. So it's interesting to see that keep going and going. So in terms of the DC voltage increasing, as our industry kind of develops, we've also seen that happen on the AC side. Predominantly a commercial interconnect or service voltage is like 480 volts, but you'll see in some cases 600 volt is available. And 600 volt AC is also very common in Canada. Well, we kind of took that a step further with our 275 kilowatt inverter and went to an 800 volt AC intertie.
Okay.
And we also provide balance of system equipment to complement that. One of the things that happened when we launched our 100, 125 kilowatt string inverters that are 1500 volt DC, 600 volt AC is many of our clients said, well, where do we get equipment rated for 600 volts? I can't just go to a panel board manufacturer and say, I want 600 volt. It's interesting because the equipment is listed to 600 volts, but it's usually under an older, enclosure standard like UL 508 or something like that dictates what, say, a molded case circuit breaker or an AC disconnect switch is tested to. And for an inverter, which falls under 1741 and IEEE 1547, the voltage can go as high as 120%, right? You've got these
Sure.
voltage restrictions that you must trip to. Well, are those panel boards actually tested to that higher voltage? And in some cases they were. They would have a dual UL IEC listing. So they would be, 600 volts and then like 690 volts. And some manufacturers were providing letters that said, yes, you can use our equipment under a 120% application or a 110% application of nominal voltage. Now, when we went to an 800 volt system, again, some of our customers were struggling. I think Eaton makes some equipment at 800 volt. ABB does. We, under Chint Group, which is a global, provider of electrical components, we were able to manufacture our own AC combiners using molded case circuit breakers that are rated for 800 volts, including disconnect switches that are rated for 800 volt applications. So this really just kind of complements our portfolio. But back to it's just common sense that it's simple Watt's law. You increase this voltage for the same power rating, your current's going to go down. Or if you, if you keep the same current and you have a higher voltage, you're going to get more power.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more. Yep. So in the greater scheme of things, though, the evolution of the 275 kW inverter and 800 volt AC systems, this is ultimately playing out by reducing the amount of materials in a, say a 10 megawatt solar plant. Is that how it plays out?
Exactly. Because for the raised voltage, the higher voltage, it means your current is lower for the same power, which means your conductors are smaller because the current is smaller.
Yep.
So there's a cost savings there in terms of, how much you're spending for conductor runs. Some of these can be for these large utility scale, this can be inverters and equipment just placed kind of far away from each other. And you've got these longer runs. This can be really helpful and advantageous in terms of cost for that.
Yep. I'm always curious also about this centralized approach or distributed. String inverters allow you to put the inverters all throughout the array, but many times you'll see them clustered, and now you even do the skidded approach as well. Mm-hmm. How is that decision made? How does a company optimize around one or the other?
Yeah, good question. So we tried to make our products as flexible as we could in terms of different applications. So you could do a large, multi-megawatt ground mount, or you could do a smaller community solar, which is only maybe a megawatt or so. And we've designed our products with the field wiring box so that it can be, for our 100, 125, you can either use a what we call a distributed architecture, which includes fuse holders and all string wiring to the inverter, or as you mentioned, you can do what they refer to as a virtual central. You're essentially mimicking the architecture of a central inverter, but you're getting the benefit of a string inverter by clustering inverters in a group near the skid mounted transformer or near the transformer itself. Um, Again, just down to flexibility. The one benefit of doing the cluster approach is that you've got longer DC string runs, and you're not doing the power conversion until you're closer to the transformer. So you can think of it as almost like free DC voltage drop. If you were to convert from out within the array, now you've already done the power conversion and you've got this long AC run to go back. You might have to mitigate that by upsizing your conductors back to the transformer to offset that voltage drop for those long runs. Um, the other benefit about using a string inverter for this, virtual central approach is you've got the benefit of the multiple MPPTs in these string inverters. In our case, our 275 has 12 max power point tracking channels, and they can increase your energy harvest in terms of reducing the mismatch losses of the number of strings that are connected to an MPPT, where a central inverter might have multiple strings connected. You've got only 2 or 3 per MPPT channel in a 275. Another benefit is uptime, right? So you're getting better energy harvest, but then if there is an issue with the inverter, and you've got a problem where the inverter is either underproducing or has failed altogether, it's a fraction of the total PV plant versus having a big central inverter that might have a problem and go down. It's a sense of scale. So it's a win-win all around.
Yep. Yep. I want to go back to this question of how products evolve. You mentioned in the pre-show that you work closely with your customers to make sure that you're designing and developing products that meet their needs. Tell us about that process, and what is the life cycle like? Because, it wasn't that long ago that the 125 was a big deal, and but now it's the 350. So I'm just curious, what is that process
really,
like?
It's really voice of the customer, right? It's the guys that are designing these systems, feedback from installers about how can we make improvements in terms of, hey, I wish, your AC terminal would accept a larger conductor because I, have to mitigate voltage drop for this installation, or something like, hey, touch safe fuse holders are great. They allow for easier O&M activity. I don't have to disconnect the wires from a terminal. I can just, turn off the system and open the DC disconnect, and then open the individual strings to do my O&M service. In terms of power levels, that's just really the future. Everybody wants to go a little bigger. We try to stay flexible in terms of our power levels for different applications. Like I mentioned, community solar versus a large ground mount that might be multi-megawatt. We're seeing projects now that are like 100 megawatts in size, and customers are saying, well, hey, that, it'd be great if I had something double the size, instead of a 125, do you have a 250? Or, if your 275 was a 350, that'd be great because I could reap the benefits of a string inverter, approach to architecture when I build these systems, but I don't have to install as many of them, that kind of thing. So that's kind of where that happens in terms of product evolution. It really comes from voice of customer and feedback from our customers.
And tell me, how do you work with the sales team? What exactly is an applications engineer, and how does it all work?
Yeah, great question. So we support all our products, going from the C&I products all the way up to the utility scale products. And it's assisting them in product selection. For a C&I application, there might be a particular inverter size that would be the best fit for their project. I mean, we have customers that are doing projects from 200 kilowatts DC up to 100 megawatts. So it's helping them select products, instructing them on how it should be installed. We get a lot of questions about, do I need the right spacing for ventilation or serviceability, or can I mount it this way, or can I bring my conduits in from the side of the box rather than the bottom? Or, I mean, you name it, Tim, there can be all these kind of questions. And that's really kind of the fun part about my job, is fielding some of these questions. And then supporting customers in things like, hey, I need this test data for this utility that we're applying for this interconnect with. They want to know, what's the harmonic content of the output current waveform from this inverter, or what's the short circuit current contribution of the inverter. These are all helping in probably pre-screening of by the utility for projects. In some cases, we provide what's referred to as a dynamic model, so that a stability study can be performed. These are PSCAD, PSSE, sometimes an Aspen short circuit model, and they run in these software programs for simulation. Many of your listeners might be familiar with like PVSys, or like designing a system with like Helioscope or something like that.
Sure.
PVSys really does a system analysis, a production and performance analysis. These other applications are really kind of introducing anomalies and seeing how the individual inverter or the PV plant might behave in if there's a voltage short, or there's some kind of voltage excursion or something like that. So,
yep.
So those are the kind of things that I support our customers with, and then assisting our salespeople with the right answers. Sometimes I sit in a sales call to support them, where they're talking to a customer and doing the same thing. Rather than an email or a phone call, it might be a in-person meeting.
We solar professionals now are all also battery storage professionals. And if you're not installing or designing and installing solar and storage systems, you will be. Batteries are so important for a variety of reasons. They provide grid services. They allow you to attack charges beyond daylight hours, et cetera, et cetera. There's a whole value stack. But what has your experience been so far? You've seen the industry go from 0 to 60, so to speak, really, right? And I mean, storage was probably prevalent in the very early days of solar, right? Because it was mostly for off-grid applications and using more traditional lead acid batteries. But now we have, large-scale stationary storage and ubiquitous residential storage available. And these are mostly grid-tied systems, mostly behind the meter, but also front of the meter. Give our listeners a taste of where you see storage having come and where's it going.
Yeah. Well, everyone knows that the utility rates are going up, right? And there can be challenges around, when you have specific loads at your site that you're trying to offset. And solar is not 24/7, just like wind is not 24/7. Sometimes the wind blows, sometimes it doesn't. Sun comes out for 12, 14 hours a day and then goes down. So what happens otherwise? Well, you might need a PCS, a power conversion system that has energy storage with a battery. And this is typically used, as you mentioned, for demand rate reduction, peak shaving. Like if it's a industrial complex that has, maybe motors of some kind, a factory that's turning on at a certain time of day, then you can use that battery, that stored energy in the battery, to offset the demand rate charge that those motors or machinery might incur. During the day you've got PV, but in other times you don't. You can also schedule it so that you're always using PV when the rates are higher, and you're charging your batteries. And then when that rate changes, you can discharge those batteries to offset that demand rate. So yeah, we're going to see more and more of this. Same with residential. I mean, you're seeing lots of manufacturers that are offering battery backup systems. It could be used for the same arbitrage or demand rate reduction or peak shaving for a home. But really, I think that those are kind of systems that are using like off-grid in terms of an outage. That's a lot of advertising I see for residential is, hey, you're going to have power if the utility goes away.
Right.
And that's either due to an outage that might be from an accident or a failure, or it might be a planned outage. I mean, here in California, the utilities are doing planned outages in terms of, if there's a storm in an area and they're concerned about, it affecting their grid or their overhead wires, they often turn off electricity to some communities.
Yeah, so solar's wonderful, only works when the sun shines, and it doesn't work if the grid goes down, right? It is designed by code to disconnect if there's
Correct.
not hardware to microgrid and a battery or some other generator to turn on and start providing power. But but in the C&I space, does the advent of batteries change the inverter space at all?
Well, you may see more microgrid applications that are using simply a PCS that operates as a voltage regulated source, and it is, quote, the grid. And then you've got PV that is connected to that source. And the PV inverter is a current source. It's going to look for a stable voltage source and connect to it. So you may see, again, more microgrid applications. Our PCSs, the Chint Power System PCSs, will operate in both a grid forming or grid following mode. They can be programmed to do that. So other manufacturers are doing the same thing, but you'll see that in more cases where there may be different applications using energy storage and batteries.
Yeah. And you've made a big splash with this this utility scale 5 megawatt hour 20-foot container. Tell us about that.
Yeah. So in terms of our large, mentioned the 5 megawatt hour battery, we developed a 200 kilowatt PCS, and we're using the same approach to energy storage as we are with PV. We're taking the, quote, string inverter approach. So we manufacture a skid mounted transformer with up to 12 of these PCS, essentially racks that can be installed with this 5 megawatt hour. And the advantage of doing this string inverter approach, again, is if one has a failure, your whole system is not down. It also reduces the short circuit current of the battery, so it can be safer to work on. And then in terms of doing a equalization of the battery strings, if you will, you can charge the battery to an equal state of charge by kind of less strings. If you've got multiple and you've got some mismatch or high resistance between these different battery stacks, that can be an issue.
I want to talk in our last few minutes together, John, about the company. You have such a storied career. You could work for really any solar manufacturer you chose to, literally.
Thank you.
And yet you choose to stay at CPS America for 8+ years now.
Yes.
What is it that in the first place attracted you to CPS and has kept you there so long?
Yeah. Well, there was a story told to me when I interviewed about an issue that happened with one of our products, or one of their products at the time. I wasn't working for them. And they were completely transparent with their customer to say, we believe we have an issue with this product, and we want to come out and do a repair for you on your product. It hasn't happened yet, but we want to be proactive and be transparent and take care of you as our customer. And I thought, wow, that's amazing. Where, some other manufacturer might want to just sweep that under the rug, like, oh my gosh, we can't. This is bad news. We can't tell this to our clients. They're going to go nuts, and we're going to lose business. It actually was just the opposite. So CPS really prides themselves on customer service and being transparent about issues that happen. And we know that, not every product is fail safe. It's things are going to break. Something's going to happen, and we will make improvements over time. So that initially drew me to the company. And then I think just the company culture in the sense of community, of working together and being collaborative on like this. There wasn't this mentality of like, oh, you've got to stay in your lane. That's not your job. We kind of have this term that Brian Wagner has coined called the triangle offense, or the Lightspeed system is another one, where we are working together as a team in different departments to support our customer and do it quickly. So there's really gray areas between our lanes, probably a good analogy, where we can easily pass information to support this client quickly and easily. So to answer your question, I think it was really open transparency, that serving our customer was a priority, picking up the phone, answering, being a live person and not just getting recording all the time. The culture of team building, team working together. It's not an us and them. We do many events together as a company, and it's everybody. It's upper management. It's people of all roles together. There's no like, oh, that's the, so-and-so, I can't talk to him because, I don't know.
Yep. Yeah. These things sound so common sense, and yet many companies do not follow these ways. And it definitely makes CPS stand out. And as I've gotten to know the company and more of the employees, it really is striking how you have this very collegial culture. It is not one of winners and losers. You're all there to ultimately win and bring your customers along with you. And you fully acknowledge that the products are not perfect, but you're committed to fixing whatever problems exist, and
we'll stand behind it, of course. Yes.
Yeah. And that is, and that goes a long way. So, well, John, I want to thank you for coming on the show. I really appreciate your time. And to our listeners.
Yeah, thank you, Tim. Appreciate it.
Oh, you're welcome. To our listeners, thank you for being here. Please check out all of our content at cleanpowerhour.com. Give us a rating and a review on Apple or Spotify. And please tell a friend about the show. That is the best way you can help others learn about this. And there's an amazing knowledge base here at the Clean Power Hour. We also have a healthy roster of events, so check out the events tab. I look forward to connecting with you, my listener. Contact me on LinkedIn or via the website. John, how can our listeners find you?
Yeah, so my email is John with an H, JOHN.Drummond, DRUMMOND @chintpowersystems.com, or our website which is chintpowersystems.com. I'm usually at every trade show. I was just at NABCEP this week, so please feel free to reach out to me, and happy to help work with you on your next project.
With that, I'll say, let's grow solar and storage. I'm Tim Montague. Take care, John.
Thank you, Tim.
Hey, listeners. This is Tim. I want to give a shout out to all of you. I do this for you twice a week. Thank you for being here. Thank you for giving us your time. I really appreciate you and what you're all about. You are part and parcel of the energy transition, whether you're an energy professional today or an aspiring energy professional. So thank you. I want to let you know that the Clean Power Hour has launched a listener survey, and it would mean so much to me if you would go to cleanpowerhour.com, click on the About Us link right there on the main navigation. That takes you to the About page, and you'll see a big graphic, Listener Survey. Just click on that graphic, and it takes just a couple of minutes. If you fill out the survey, I will send you a lovely baseball cap with our logo on it. The other thing I want our listeners to know is that this podcast is made possible by corporate sponsors. We have Chint Power Systems, the leading three-phase string inverter manufacturer in North America. So check out CPS America. But we are very actively looking for additional support to make this show work. And you see here our media kit with all the sponsor benefits and statistics about the show. You know, we're dropping 2 episodes a week. We have now over 320,000 downloads on YouTube, and we're getting about 45,000 downloads per month. So this is a great way to bring your brand to our listeners, and our listeners are decision makers in clean energy. This includes project executives, engineers, finance, project management, and many other professionals who are making decisions about and developing, designing, installing, and making possible clean energy projects. So check out cleanpowerhour.com, both our listener survey on the About Us and our media kit, and become a sponsor today. Thank you so much. Let's grow solar and storage. The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.